In this video, we look at transformations of cubic and quartic functions. So we'll start by making a table of values. We'll start with the cubic function, f at x equals x cubed. We'll just make a table of values to get us started here. So we'll choose some x values, figure out the y values, and plug those in. So I'm going to start with some fairly basic x values close to the origin, make it easy. Negative 2 cubed is negative 8, since negative 2 times negative 2 times negative 2 gives us negative 8. Negative 1 cubed is negative 1, 0 cubed is 0, 1 cubed is 1, and finally 2 cubed works out to 8. So if we go ahead and graph these values, what you'll see is you get a table that looks, or sorry, not a table, a graph. It looks more or less like this one here. Let me just shrink that up a little bit so that it'll fit on the page. So you can see those points are there. It's clearly not a straight line, and in fact it's a nice curve. The curve should look something sort of like this, and I'm just going to kind of connect the points here as we go. Maybe not the best graph, but you can kind of get a sense of what it looks like. So that's the cubic function. Notice the end behavior here, that as x goes towards negative infinity, y is also going towards negative infinity. As x goes towards positive infinity, y is going towards positive infinity, so you can see what the graph looks like there. So that's the base function for the cubic function, the base cubic function. We can do the exact same thing here for the quartic function. So x and y all use the same x values. Negative 2 to the power of 4, that'll be positive 16, because we multiply negative 2 by itself 4 times. Negative 1 to the 4 is 1, 0 to the 4 is 0, 1 to the 4 is also 1, and 2 to the 4 is 16. So you'll see that once we go ahead and graph that one, see if I can get a picture of that one for us. Yeah, there it is. You know what, I think I'll, instead of shrinking it up a whole bunch, I think I'll just slide it right over to the side here. So hard to see maybe, but once we draw our curve through the points, you can see it looks like a very, very, very steep looking parabola of sorts. Things grow a little bit quicker when they're to the power of 4 rather than 2, so you get this happening. Again, that's our base function. Notice the end behavior. As x goes towards positive infinity, y is also going towards positive, sorry, as x goes towards negative infinity, y is going towards positive infinity. And as x goes towards positive infinity, y is going towards positive infinity. So those are the two base functions that we're going to look at here, and we're going to look at the transformations of those functions. The good thing here is that all the things that applied to all of the other functions we've looked at apply here as well. So just a reminder here that the a value was a vertical stretch or compression. It also was responsible for a reflection in the x-axis. The k value does the horizontal stretches and compressions, and well, we'll start with that, horizontal stretches and compressions. It's also responsible for the reflections in the y-axis. The d value is a shift horizontally, shift left to right. And the c value is a vertical shift. So up or down. And just a reminder that we need to apply the stretches, compressions, and reflections first. So stretches, compressions, reflections are applied first. And then we can apply the translations or the shifts. Alright, so here's an example. What transformations have been applied to the cubic function f at x equals x cubed in order to get this function listed here. Now one thing that I noticed very quickly here looking at this is there's a slight difference in how this looks compared to this part up here. Notice up top the k is factored, so we're going to factor that k value out so that we can get the correct d value. So let's start there. We're going to factor that half out of the part inside the brackets. So we'll have negative 8. We'll put that half out front of a set of brackets, and we'll divide everything in the brackets by 2. So by half. Half x divided by half is just going to be x. And then 2 divided by a half. 2 divided by a half will give us 4. And we still have the cubed and the minus 3. So when we look at this, the negative 8 here will stretch by a factor of 8. So this is going to be a vertical stretch by a factor of 8. By a factor of 8. We'll also have a reflection because of that in the x-axis. So we get a reflection in the x-axis since that 8 is negative. The half is a horizontal stretch by a factor of 2. The 4 will be a shift to the right. Shifted right 4 and shifted down 3. So we can now take our base function, the one that we drew on the previous page, and apply these transformations to it and get our new graph. So question here only asks what transformations were applied, but we could actually go ahead and apply those transformations.